Hi everyone, we are Kernel-Forge. GPU kernel operating vision is still very different on machines and manually tuning kernels for each model and hardware configuration. So we at Kernel-Forge try automating this process. We give it a model, the workload, and the target GPU. It provides the workload, generates candidate kernels, checks them for correctness and compiles it, and then actually runs it on the target hardware, and then hardware becomes the feedback loop. If a kernel is faster, then we keep it and use the performance data to guide the next iteration. Over time, the system continuously searches for better implementations. So it runs the optimization memory will store different methods which it tried adaptive tiling strategies, fusion pipelines. We store them. If it is not good, we have it as a lesson, and then the agent tries generating much better candidates in the next iteration. So the component has our system has three main components. One is the optimizer, the development target, as well as the hardware itself. The key idea is that the hardware becomes the main part of feedback loop, and then rather than optimizing against a generic performance benchmark, it measures the real performance of the exact GPU where the model is going to run. And then in our demo, using the same model, same GPU, and same units, we achieved a 7.03% improvement in the end-to-end token throughput without changing the model weights. We used more Qwen 3.5.8B model as our target model for which we want to increase the performance at. And we started with a gated delta net as a starting point. This same loop can be used for other optimization layers as well, like RMS, norm, or SWIGU fusion layers. And later on, we can just move on to multimodal optimization and other stuff as well. And this isn't about one universally optimizing kernel. It's about automatically finding the best implementation for this model in this workload and in this hardware. So today we are demonstrating this on one component, which is the gated delta net on a Qwen 3.5.8B model. And it can be extended to other layers like normalization, attention, quantization. And we turn this manual engineering task into a continuous hardware in the loop optimization process. So we also open sourced our harness as well in GitHub, which anyone can import it to their Nemoclaw Hermes agent, and then write kernels for any model which is running on their hardware. And then the kernel is also open sourced in Hugging Face. We also gave the instructions on how to load the kernel to the model, and then they can run it. So people can see. So initially when we ran the baseline, it was running at 205 tokens per second. With an accuracy of 50% on GSM. We took some sample on 10 data points, and it was having 50% accuracy. After with our adapter, the updated kernels, we improved the tokens per second to 220 tokens per second with the same accuracy. So yeah, we tried running it again at a different iteration as well, and we still have maintained the same accuracy. So thank you.